Hello everyone, welcome back again to Excellent Solutions, a guide to score 300 plus in Jamb. Today we will continue with physics and we are continuing from question 11 to 17 under terms associated with wave motion, that is frequency, wavelength, wave velocity and the period of wave. So if you don't forget, I posted question 1 to 5 and 5 to 11, 5 to 10 in my previous videos. So today we are continuing from here. These questions are brought to you from this book, Excellent Solutions, a guide to score 300 plus in Jamb. This is comprising questions topic by topic that can lead you to score 300 plus in your Jamb. Our question 11 here says, the wavelength of a signal from a radio transmitter is 1500 meters. So we now have our question 11, lambda equals to 1500 meters. And the frequency is 200 kilohertz. So F equals to 200 kilohertz. This is the same as 200 times 1000 for this case. We now have 200,000 hertz. What is the wavelength for a transmitter operating at 1000 kilohertz? So we have another frequency F, which is 1000 kilohertz. This is the same as 1000 times 1000, and we now have 1 million hertz. So if this is the case, we have two frequencies. This one should be F1, this one F2, this one should be lambda 1, and we are asked to look for lambda 2. So if this is the case, since it is a radio wave, remember we have velocity V equals to F lambda. So we can now say V1 equals to F1 lambda 1. And we can have V2 equals to F2 lambda 2. So for this case, since it is a radio wave, all radio waves or all electromagnetic waves have the same velocity of 3 exponential 8 meters per second. So that means V1 equals to V2 for the radio waves. So we can now have F1 lambda 1 equals to F2 lambda 2. If we are looking for lambda 2 now, we divide both sides by F2, dividing here by F2. So we are going to have lambda 2 equals to F1 lambda 1 over F2. So we now have our lambda 2 equals to our F1 here is 200,000. We now have 200,000 multiplied by our lambda 1, 1500, divided by our F2, 1 million hertz. So in this case, if we look at this, we have 5 zeros here, you can go with 5 0. This 1 0 go with 1 0. So 2 times 150, we now have lambda 2 equals to 300 meters. So if we look at our option, we have in option B 300 meters, and the answer is option B. The next question here is question 12, and this says, if the wavelength of a wave traveling at a velocity of 360 meters per second is 60 meters. So here the velocity V is 360 meters per second, and the wavelength lambda is 60 meters. The period of the wave is, so we are asked to look for our period. So if we remember, V equals to F lambda, and this F frequency is the reciprocal of wavelength of period. So we now have 1 over T times lambda, and this now gives us 1 times lambda, we have lambda over T. So if V equals to lambda over T, if we make T the subject, we now have T equals to lambda upon V. So and if you look here, what our lambda is 60, we now have 60 divided by our V is 360. So 0 cancel 0, 6 here 1, 6 here 6, we now have 1 over 6. So if we look carefully here, 1 divided by 6, we cannot have a whole number. So we can now say T equals to 1 over 6 which is 1 divided by 6, we can't have whole number, so 0, put a point, make this one to be 10. 10 divided by 6, we have 1 remainder 4. We now add 0 here. 40 divided by 6, we have 6 remainder 4. And still 40 divided by 6, we have 6. So this is the same as 1.66, and this is approximately equals to 0.17 seconds. So if we look at our option, in option C we have 0.17 seconds. The answer is option C. The next question is question 13. This question says the wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. So if you look here, the velocity is 420 meters per second, and the lambda wavelength is 42 meters. What is the period? So we are asked to look for the period. We call what we have before, T equals to lambda upon V. And our lambda is 42 upon our V is 420. So 42 here, 1, 42 here, we have 1. This is now the same as 1 upon 10. 1 divided by 10, we have 0.1 second. So our period here is 0.1 second. If we look at our options, option B, we have 0.1 second. The answer is option B. The next question is question 14, and this question says, a boat at anchor is rocked by waves whose crests are 100 meters apart. So lambda equals to 100 meters. And whose velocity is 25 meters per second. So V equals to 25 meters per second. At what interval does the wave crest reaches the board? So we are looking for interval, which is time. So if we are looking for time, we say T is equals to lambda upon V. And this gives us lambda is 100 upon our V is 25. 25 here 1, 25 here 4. So we now have 4.00 seconds. If we look at our options, in option C we have 4.00 seconds. The answer is option C. The next question is question 15, and this question says the distance between two successive crests of a wave is 15 centimeters. So lambda equals to 15 centimeters, which is the same as 0.15 meters. And the velocity is 300 meters per second. Calculate the frequency. So V equals to 300 meters per second. We have to calculate frequency. So remember we have F equals to V upon lambda, which is the same as our V, 300 divided by our lambda, 0.15. So this one is now the same as saying 300 divided by this one. We take this decimal point 1, 2. We can now have 15 times 10 raised power minus 2. So if this is the case, we can now have F equals to 300 divided by 15. This exponential, when it goes up, it becomes times 10 raised power plus 2. So 300 divided by 15, 15 here, 1, 15 here, we have 2. So we are now left with 20. So this now becomes 20 times 10 raised power of 2. And if we take our point back here, this now becomes F equals to 2.0 times 10 raised power of 3 hertz. And if you look at our option, in option C, we have 2.0 exponential 3 hertz. The answer is C. The next question is question 16. And this question says a vibrator causes water ripples to travel across the surface of a tank. The wave travels 50 centimeters in 2 seconds. So it travels a distance of 50 centimeters in time, 2 seconds. And the distance between successive crests is 5 centimeters. Calculate the frequency of the vibrator. So we have lambda equals to 5 centimeters. We are asked to calculate the frequency. So remember, F equals to V upon lambda. And this velocity, we call that V equals to distance upon time. So we now have distance upon time times 1 upon lambda. So this gives us distance upon t lambda. So F is now equals to our distance. We have 50 divided by our time is 2 times our lambda is 5. This is in centimeter. This one is also in centimeter. So centimeter cancel centimeter. 2 times 5 we have 10. So this is the same as 50 upon 10. And this now gives us 5 Hertz. If we look at our options, in option A we have 5 Hertz. The answer is A. The next question is question 17. And this question says, if a light wave has a wavelength of 500 nanometers, so lambda equals to 500 nanometers, this is the same as 500 times 10 raised power minus 9 meters. Nano means exponential, minus 9. So we can now, okay, let's leave it here. In air, what is the frequency of the wave? So we now have C is equals to 3 exponential 8 meters per second. We are looking for frequency. So our frequency F is equal to C upon lambda, where C is the speed of light in air. So this now becomes 3 exponential 8 divided by 500 exponential minus 9. So this one, we can now make this one to be equals to, or let's see, F is now equals to 3 exponential 8, or let's say 30 times 10 raised power, we take this point 1, we now have 7 divided by this one. If we take our point 1, 2 backwards, so it's now equivalent to 5 times 10 raised power minus 7. So looking at this here, 5 here 1, 5 here we have 6. So this is the same as saying 6 times 10 raised power 7. If this exponential go up, it becomes plus, so plus 7. So our frequency is now 6.0 times 10 raised power 14 Hertz. If we look at our option B, we have 6.0 exponential 14 Hertz. The answer is option B. Thank you for viewing. Kindly comment on this video, comment your experience, like and share, and also subscribe to my YouTube channel for more exciting videos. Thank you for viewing.